It's Saturday morning, everybody is outside, apart from Marcos, that is a diligent student in big data, struggling with his assignment of machine learning. Guys, I really don't understand this algorithm. Marcos, I can help you. I'll do a nice graph for you.
Man, that can't be. Why do I have to wait so long? Why isn't it working properly? I have the feeling my computer is exploding. And sci-fi really doesn't help me. It's like machine learning nice, but applying it horrible. Let's think about it. Hey cat, what do you think? Should we do something like in Python? No. No worries. Not the snake. Python, the programming language. Yeah, I think we could do something nice there. Something like a cool and nice library to use. That's easy to use, where you don't get so much frustrated. With easy steps, you can quickly run a machine learning algorithm. Man, that would be cool. We could name it SciPyLearn. No, wait, that's not good. What about SciLearn? SLearn? SKLearn? Yeah, SKLearn. What do you think?
Back in 2007, in a hot summer, David Cournapo started developing Scikit Learn as a part of Google's Summer of Code project. Later on, Mathieu Bruchet joined the project and started using it as well for his thesis work. Not later than 2010, INRIA, the French Institute for Computer Science and Automation, got involved on first release. This can be considered a milestone, as finally there was a Python library that was easy to use for machine learning. Ever since, many things improved by many releases.
Come on, Julia, no. Come at me with something less theoretical, less historical. I have this data set with many variables and I have to do a classification analysis.
And Marcus was right, because it was not an easy classification, the one that Lending Club was doing. Lending Club is an online peer-to-peer credit marketplace, and they want to evaluate the creditworthiness of their borrowers. Of course, there are some variables that are truly correlated with the output, whether to give or not give the loan, but some of them are very hard to study, and we have 75 different variables in different formats: categorical, numerical, dates. But we are sure that Marcus will understand everything of the algorithm thanks to our practical simulation when cooking is the new coding. MasterChef Python, welcome! So, there are the chef, which is equal to the coder in reality, the first judge, logistic regression, the first model, then we have random forest, second judge, and then finally the third judge, XGBoost, while Carl is the MasterChef owner as well as the metrics. Performance definition. How we are gonna score the model? We want to measure 0 and 1s, so we need to take a relevant sampling of both classes 0 and 1, thanks to the SMOTE algorithm and not with the random or undersampling. We measure 8 main parameters, and Carl is gonna explain you how this game is gonna represent the machine learning algorithm.
Welcome, my name is Karl Westphal. I am the inventor of MasterChef. Also, I have 53 restaurants with 3 Michelin stars. I have some very exciting news for you. We will be launching MasterChef Python Spain, and I will be looking for a new jury member to head the panel down south.
Like if you were one of the chefs that is cooking for Carl, the first thing you need to do is data exploration. So you need to know what there is in the data set, and you have truly to look into all the details to find out all the peculiarities that we have. Beautiful. In this case today we are cooking a lasagna. Data preparation means before cooking we actually need to do NA removal, different operations in order to make the ingredients ready. our ingredients are the variables of the model, so the columns that we are used to see in a CSV file or in Python. Oops, sorry. Moreover, we start with the cherry tomato. Done with the first ingredients, we go to the second one, onions. Nice tattoo, by the way. And here we want to show you how precision is relevant, the theory behind the cutting skills that you have are fundamental to prepare your ingredients properly for your recipe. Different perspectives can help, of course, plotting the data in 3D, in 2D, however you prefer, different charts. Will absolutely help you. And then the second point that we want to stress here is that it's a very long operation. So that's why the video is very long, and now I don't know what else can I say. I was crying at the moment while I was cutting the onions, and once the onions are cutted, you just store them to make sure everything is ready, in order, and you keep track of what you've done. Scaling is necessary in the case that we want to make sure the variables have the same weight for the model. For example, income and number of children. Okay, next step are the manipulations of the features. In case we think to find better features, we can mix them, feature engineering, of course. In the case of Lending Club, we created 3 basic features: the ratios of funding invested, the customer has a large income, top 80%, and whether the customer receive a low interest rate. Why we did it? Because, for example, in this case, when you have a long tail, you do a Pareto analysis, and you can differentiate the customers. Here we are creating bechamel with salt, milk and butter. Last step before jumping into the modeling part is preparing the lasagna layers. We have already prepared layers, but we are gonna do homemade ones as well. The egg label encoding, we split the yolk with the white part, and then we make our own pasta. This can be considered as binding or dummy variables, depends on the case. It's a bit maybe too much, so it's a bit different in reality, but at least gives you the idea that you split into different categories. Finally, we are at the modeling part. Shown here is the first ingredient, the first variable that the model is processing, and this one is a time lapse of the baseline, the logistic regression that is cooking all the dishes, all the rows, all the receipts according to his attitude, let's say, of the chef. So our idea is that all the models will cook the receipts in a different way, and we need to take into consideration more than one model to see which one is performing best. After the baseline, after the logistic regressions, we also used the random forest because it has a different structure, a different nature, and to get a better result, the XGBoost. Which one is the best? We need to wait for the metrics. We need to wait for the result, and important, we need to mention also the time constraint that with the XGBoost is gonna take longer, but we will gonna obtain a better result. Two important key differentiation for the models are the feature selection and the hyperparameters optimization that always have to be done at the end to get better results. And then we are finally done and we go to the model evaluation. So here our 3 different models cooked all the receipts in the datasets according to their preferences. And these are the results. So 0, it means not accepted. In order to be more accurate, we also did cross-validation, which means divide the training set in different splits and then test in the other part of the training set.
We are here with the finalists of MasterChef Python in Spain, XGBoost and Random Forest. I have both valid you on the training set, but Random Forest was faster. Therefore, you win. Good luck with the test set.